Welcome everyone in the next session of urban and suburban transportation concept. In the today's session, we will try to understand that what are the different aspects which we need to consider while design and plan for the public transportation network. It is very much important so that because as a transportation planner, the characteristic of the good transit system should be fast, frequent, and reliable. And again, to beat the issue of a congestion and also to provide the alighting and boarding facility to the very huge crowd. So we need for the same purpose, if we want to design the coordinated public transportation system, so we need the dedicated infrastructure for the purpose so that we can get the reliable operations, better planning, coordinated scheduling, and we can integrate different type of transportation modes such as metro, such as BRT, such as light rail transit, as well as the public car as well. This is one of the typical example from the Australia metro system. Uh, as you can see here, only in this figure that we have different type of a station, different type of a trains are arriving at the same time on the multiple stations. So we have a single station, but we have different platform. So today lecture is all about that. As you can see here on like in the below picture, we have the two trains are arriving at the same time. One is on the left hand side while the other one is on the right hand side. Okay. So today's session is all about so that how we can plan or how we can understand when the different trains depart and arrive from different location at the same time. So today's session is in the today's session we will try to understand that how to reduce waiting time on that specific platform while to provide the such type of a planning, such type of a coordinated planning so that the passenger can alight and aboard from the same terminal, from the same station through in the different directions. Okay. Today, we will also try to understand the functional design. We will also try to understand transfer stations, coordinated scheduling, timetable information, and so on. So we have look in the previous slide is we mentioned that on the same platform, different trains are arriving. So there will be a transfer from one station to another, or might be there is a possibility that one train arrive at 8:80 and another one arrive at 8:02 or 8:01 or maybe exactly at 8. But to change to alight in board and exchange the passenger between both trains, we need a transfer. So transfer is not required in the radial network, which only connect a single way or which only connect from the rural area to the rural with the urban areas. And if we have the highly integrated network, which we explain and understand in the previous lecture where we gave the typical example from the Japan as well as from the Beijing and Shanghai as well. And if we have the high capacity networks, okay, so in those two different type of a transit station, we do not need the transfer. Okay, so now you need to understand what is transfer. Transfer is basically to change your commute from one line to another line. This is called transfer. Okay. So now the next question is that how we can reduce the inconvenience to transfer from one line to another line. For that purpose, we need to understand those 6 points. The first one is there is a term which is called the perceiving time or perceived time. We will also try to understand that one as well. We will try to understand that how we can design the function of different line. We can design the transfer station, how we can come up with the coordinated scheduling. Coordinated scheduling means that the train arrive from different location at the same station at the same time, and how we can give the joint tariff so that the passenger should not pay for each and every individual half kilometer at every time. Okay, and also we need to integrate all those timetable together as well so that we can provide the huge accessibility and mobility option to the passenger. The first point through which we can reduce the inconvenience is called the functional design. Okay, in the functional design, a transportation system can be conceptualized as the set of relation so that we can understand that what is the set of relation between those two different stops, different nodes, different networks, and where we have the maximum demand flow and infrastructure, how the infrastructure is actually integrated and how it can handle the commute between those different links or nodes. Okay. So the high capacity lines are usually the independent line, because if you have a lot of passenger demand, we cannot integrate it. So we do need the right of way category A, where we have the completely independent and completely dedicated lines. While the independent network needs efficient transfer and feeder services. Of course, the same line would be again connected in the different branches in as well as is the different trunks as well as the nodes so that it can serve the high capacity demand. Okay, it's typical example you can see here from the Tokyo subway station map, that how different links are divided or connected across the whole city. So this is the one way through which we can reduce the inconvenience of the traveler through functional design. Okay. So the second point is the how we can reduce the reduction of a travel time, the or which we call the perceived time. In transport economics, the value of the time is the opportunity cost of the time which travelers spends on their journey. Uh, this make it the amount that the traveler would be willing to pay or will pay in order to save time, or the amount they would accept as a compensation for the loss of a time. But what here we actually perceive, it's a simple statement that when we are trying to wait for the public transportation, we think or we maybe sometime think that we spend more time. For example, if you are staying there for 2 or 3 minutes, and as we are not connected in any type of activity, so we are only waiting for the same public transportation to arrive. So we think that we maybe wait for maybe 5 minutes or maybe 7 minutes. Okay. So now the question is the travel time with transfer must be less than the travel time in the direct service. Okay. Here द क्लॉक टाइम वर्सेस परसीव टाइम, दोनों में फर्क क्या है कि हम लोग अगर 1 मिनट का इंतजार कर लेते हैं देन वी फील दैट वी स्पेंड देयर 2 or 2.5 minutes. So of course the perceived time is longer as compared to the waiting time. चूंकि हम लोग when we wait there for a while, okay, but the same time we perceive it that we have spent more time. Okay, and the perceived time and the clock time is always not the same or not the equal. Uh, to reduce the inconvenience, what we can do, for example, if the same person need to change the grade from one line to another, if he need 1 or 2 minutes, So the same line should be designed in a way that this, when the same person arrive there, so he can catch transit, the public transport with a very limited time. Its typical example is Munich U-Bahn and Schnellbahn services, which is provided across the whole city, which is connected in a very in the way through which the inconvenience is reduced. Okay, as you can see here, we have different streetcar and bus services and tram services as well. The third point is that how we can reduce the inconvenience through the design of the transfer station. Okay, so usually we have these six factors which we need to consider whenever we are thinking or building or planning for the public transportation. The first one should be the location of the transfer station and how we can make it efficient, what is the durability, how much we can rely on that, and how much different type of a public transportation can operate from the same line, mean flexibility, and of course we need to consider the cost and safety as well. Its typical example is Beijing, China. As you can see here, the different type of a paratransit is moving across the same station. This is the one of the typical station in the Haidian district in the inner circle is you can see here. Okay, so इसका मतलब basically यही है कि different type of the modes should be connected to serve the same line as the feeder line. उसको feed करे, खुराक दे उसको, खुराक मतलब उसको passenger provide करे, ठीक है? And its typical example is Scheidplatz in Munich as well. As you can see here, the same lines actually arrive from different locations at the same time. Okay, so this is its typical example. And again, all those lines are connected with the bus line 140 and 141 and 99 with 1 or 2 minute delay or transfer. Okay, so for example, from different locations, people can arrive here to the same lines which is moving again in the different direction, and all those feedings lines are scheduled after 1 or 2 minutes so that the passenger can easily alight and aboard and sit in the bus without waiting time. This is one of the typical example of the figure of the Scheid plots. As you can see here, we have one line here and two and three lines here and four line here. So the train arrive from different location at the same terminal at the same station at the same time. Okay, this is a typical example of the coordinated scheduling. So the next topic we have the coordinated scheduling. Coordinated scheduling to understand that concept, so we need to understand the timed transfer system network. First one, how we can tackle up our headways length as well, and what type of a transfer or what is the classification of that specific transfer we do have, and how we can coordinate between different local and express trains. So we will try to understand those one by one. Time transfer system, or which we call TTS. TTS is basically the concept when we provide the or design or model the headway at the pulse. Pulse means after exactly the same digit. For example, if you say that there will be the headway of the 5 minutes, so the first line will arrive at 5, the second one at 10, third one at 15, and so on. Okay. But if you think that we will schedule it the headway of a 15 minute, so we will start with 15 and then 30 and then 45 and so on. Okay, so we need to maintain the same headway. Number one. Second is, so all lines should arrive at the same pulse line, at the same headway, at the same time. So for example, if the if you want to plan or design for the TTS, so in the TTS, all the vehicles should arrive at 8:05. Okay, and if you are planning for the 10-minute headway, so all lines from different locations should arrive at 8:10. Okay. All trains are waiting a few minutes for passenger exchange. Okay, like 1 to 2 minutes. Of course, we actually need that. And a typical example can be observed and seen in the Munich, Germany, as well as of the Scheideplatz. As you can see here, is we already mentioned that there should be the same pulse or the same headway. So here you can see here, this is the hours and this is the days, starting from the Sonntag bis und Freitag, from Sunday till Monday. Okay, so as you can see here, we have the pulse repeated at every time. So like 3:23:43. So means after we have the headway of the 20-minute. 3:13:23:33:43:53. Okay, so according to your demand, so we have actually we need to design the headway. So this is the typical example of the coordinated transfer station of the different underground lines at the Scheideplatz of the U2 and U3. Okay. So the transfer station where we need to consider that. So if we have the two lines are coming from the short headway, we need to understand that one as well. If we have the long, if we want to integrate longer and shorter headway, if we want to connect shorter and longer headway, or if we want to connect longer and longer headway. So those are the different typical examples. Classification of the transfer, we can reduce it to understand the different three cases. In the first case, we will try to understand that if all the lines are terminating at the terminal station. Okay. And in the second one, we will try to understand if all lines are intersecting at the terminal station. And in the third one, we will try to understand that if some lines are terminating and some lines are intersecting. As you can see here, this is, for example, if we consider the lines from different three locations at the same point, where we have many suburban lines which are terminating. So the coordination between lines is actually required, and we can easily apply the time transfer station protocol here very easily. If we talk about that one, that for example, how it is possible if those feeding lines, those feeder lines want to serve the trunk line, so they should arrive 1, 2, or 3 minutes before that to design that trunk line. So we can easily design that one as well. For example, if the same trunk line is arriving at 8:02, so all those lines should arrive at 8:00. So we need 1 to 2 minutes. And again, it is completely dependent on the design of the same station. Okay. If we have the similar lines, transit lines which are intersecting or crossing at the same one point. Okay, so this is very, very difficult, which might cause a lot of delays because at the same station, 6 different lines are crossing. Okay, so this here we might have the complications. And this is another line when we have the two feeder lines are the intersecting the trunk lines. We want to apply TTS here, but after the departure of the trunk line, maybe or before the trunk line. Similarly, we have another example if the two lines are terminating while other 6 lines are intersecting. So those are just different scenarios that you need to understand. This is the typical example from the New York. Okay, you can see here. And also could be seen in Peshawar as well, where we have the express buses, we have the local buses, and so if we have the local buses, so the same local bus will actually stop at each and every location. Okay. express line, the local lines, and the express line will only stop at the specific station. Okay, is you can see here. So this is the difference between local and express line. Local lines will usually take by all those passenger who want to go for a shorter journey, while the express line, if someone want to take the outer ring to the inner ring within the less time, because they will not stop at every station. Next one is all about how we can reduce the inconvenience of the passenger by providing the timetable information. This is very much important, because if you did not provide the timetable, in the same timetable should be displayed at the station, as well as it should be connected with their smartphone, Android phones as well. So as you can see here, we have the if we can provide the uniform headway and timetable information, that will reduce the inconvenience of the passenger. Okay, is you can see here that if we have the similar headway for the arriving, as well as of the in the departing, so the same figure or the same pulse or the same headway figure will be remembered then. Okay, its typical example could be seen here. As you can see here, from Monday to Friday, we have the headway after every 10 minutes, which is starting with the word digit 8. Only we have the in the Saturday or in the Sunday, we have only the different locations. Okay, so the headway is again starting at 10, but the time here we have the starting at 11:08, and here it's starting at 11:06. Okay, so we have the headway. So this is very much important to provide all those information, and that should be displayed. So those are all the aspects through which we can reduce the inconvenience. If you have any